The history of our company has been, in fact, our company was created more than 35 years ago. And it's a family business. It was created between my father, my brother, and myself. We come from the powder world. That's mean, one of the first technology we developed was how to handle powder in a closed way and safe way. That's why one of the first technology we provided was called PTS, Powder Transfer System, which after that I will show you how it works. This technology is quite unique because one of the first applications we were able to provide was how to charge powder safely to chemical reactors. In fact, before this technology, mostly operator will open the reactor, will open a manhole, dump the powder into the reactor, and if you have flammable solvents, you get some air coming inside the vessel, and that's in fact very risk with dust explosion. That's why our technology was able in fact to close the process to make it very safe. And in fact, luckily we could save some life as well through that, because often you had accidents which could lead up to fatalities. That's why it took many years. It took more than 10, 15 years that people accept these technologies. Will accept it as it's a new concept, because there were, when you bring new concept on the market, you have always concern. You have to prove, is it so safe? Is it really can handle all my different material also? But today, I think we have been able to provide to most major chemical plant, pharmaceutical plant in the world. After that, the question comes, great, my process is safe, but my powder is toxic. That means, how can I protect my operator not to be exposed to product? That's why we start developing as well concept to protect people not to be exposed to the materials, because the powder could be highly toxic either for chemical use or for pharmaceutical. That's why we developed many solutions to do that. After a big milestone, we made the acquisition of a company called Jet Pharma. It's a Swiss-based company more than 15 years ago, specialized for micronization, which means how to do to decrease particle size to particle less than 10 micron, mostly for inhaled product. This company had as well isolator technology, and through that we could as well provide new technologies for protecting people. Further back, we grow the company internationally because there is a need as much in Europe, in North America, in Asia. And the last 3-4 years has been quite active, to be honest. We did an acquisition of a company in Netherlands specialized for aseptic fill and finish. That's why how to fill vials, syringe, and so on. Another company called Extract Technology, which is a UK-based, US-based company well known for isolators technology, from a downflow booth, an isolator or so. And the last acquisition was a company as well in England called AWL, specialized for continuous chemistry. And in fact, the reason of this acquisition is that DEC is not just an equipment supplier, but we are a solution provider. That's why we supplied complete solution. And we build all this technology to achieve what we call now our end-to-end solution. That's, let's say, the background on how the company evolved in order to become a global provider of process solution. That's why the key solutions that we provide to our customer in the market are, as I say, starting what we call from the molecules, which is a chemistry, because now we can provide solutions for flow chemistry. And that means we can provide technology to make reaction, crystallization, filtration. And then after you have so-called powder processing, because when you get a powder out of a dryer, you need to process it. That's why you have to mill it, you need to transfer it, you need to blend it also. And then after that, you go as well to the packaging, which means that you can package powder either in bulk with larger quantities, into bags, big bags, or to go very small amount, even in vials for milligram level. That's why that's a different technology. And most of the technology are patented technology, unique, because we try always to advance the market, always to find new solutions in order that you solve bottleneck in the industry. That's why we try to define and move the border to the industry to help them to make it safer, better, and more efficient as well. That's why this technology, we don't sell it only as a single unit, but we can integrate them as a modules into larger operation. End-to-end solution, as we express in the term, is a technology that you start from one side to go to the other side. A lot of the industry, end-to-end is misused a little bit because mostly it's when a company provides a given process unit, it will look a little bit downstream and upstream, but it will be still on his own equipment concentrated. DEC has a vision to bring it to the full extent. That's why really our end-to-end start from the molecules to the final dosage form. And in fact, is to design for pharmaceutical for the future. Continuous process is kind of the grail of the pharmaceutical industry. And still is not there because there's a lot of complexity in terms of validation, in terms of modularity also. And that's why we have developed different technologies that you can bring really to a complete operation. And really starting from what we call the raw material handling, where you handle raw materials, you go through chemistry, you can have to downstream process up to the final packaging, even moving to the patient, even to go to pharmaceutical compounding or personalized medicine. That's why still developing all this platform take times. We have already achieved a large part of it, but we continue. And now is to convince the market as well, it's a right approach. Our concept of advanced configurable process plant comes from the point that going to this end-to-end solution to do this complete process operation. One of the issues mostly when you're manufacturing an API product, that most customers need to be multi-purpose. Now a facility need to be able to have different process, different operation. And as we are promoting what we call flow chemistry, continuous process technology, the market sees it as a very rigid process because you start from one side and you finish at the end. But the question is, tomorrow I want to produce another product. How do I do? How do I reconfigure my facility? Because if I consider to a batch process, you can easily stop a process and you move to another operation also. In continuous, the part is much more compact, it's much more efficient, but it's one single flow. That's why we develop a modular operation. In fact, each modules, which we will explain or maybe show afterwards, could have different steps. Each is a process unit, we call it. One process unit could be a reaction step. A process unit could be crystallization, could be filtration and drying. And this means that you can have this as a single operation and you can move them around and reconnect them in different process flow. And that's become quite advanced because they are all equipped with utilities, with communication channel in terms of automation point of view. And as soon as you put them together, it will recognize again its position on fully automation and data recording integrated. And through that, you can really reconfigure operation in very limited times also. And that's mean after you have the full potential of this continuous, semi-continuous process. Because what is the target is to decrease at the end the facilities. That's why you can decrease sometime up to more than 50% or more. You decrease the utility requirement. That's why it's much more in terms of energy consumption, in terms of waste. You have much better efficiency, you have a higher yield, and you can as well produce some product in a different manner that was difficult to produce in a batch process. And now with this modular approach, mean that you can slowly go even to personalized fabrication, because you can make smaller batch, you can clean the system, reconfigure it for another batch, and what could have last months of operation validation, you can do it now in days. This is where DEC is developing his platform of real end-to-end and true end-to-end solution from the molecule to the final dosage form in a modular manner that you can get the full flexibility of the facility of the future. The PTS technology is one of the major technology we have developed as a company. And as I explained, is the start of the company, the growth of the company. This technology allowed to handle powders, which could be from very fine materials, sticky material, quite cozy materials also. And in fact, the complexity was, how can you handle all of the different material with the very efficient technologies? If you compare to liquid handling, liquid is much more easy, I would say, to handle. That's why you have different type of pumps to convey liquid. But for powders, the traditional way was to handle either a manual operation with a shovel operation or so. And this is where the technology, the PTS, really was quite a mastering the possibility to handle powder like a liquid. That's why the technology is developed. It's a so-called vacuum pressure technology. And this allows effectively to move powder from a different packaging, from a bag, from a drum, from a big bags, and to feed it into a process in a very safe way. That's why what is unique is, in fact, the filtration. We developed quite a unique technology of filtration on using a flat membrane. And this flat membrane was able, in fact, to control how we were able to move powder at a very low velocity on high concentration. That's why it's a vacuum pressure system. With vacuum, we fill the chamber. With pressure, we empty it. That's why if you imagine this to be a vessel, like a reactor, if you have flammable liquid, you don't want to get oxygen. If you have hot vapors, you don't want the vapors to rise into the chamber. That's why this technology, with this vacuum pressure technology, allowed to move the powder in a slow motion into the chamber. We can filter it. We can remove oxygen by putting the chamber on the full vacuum. And after, with the inert gas, like nitrogen, argon, we can discharge it into the vessels in a safe manner without any gas exchange to the system. That's why this vacuum pressure technology really mastered the way we can handle powder from very small amount, maybe a milligram, to tons. And that's why our slogan is said, from the milligram to the ton, or the ton to the milligram, because usually you start from large and you finish as small as the last packaging. You can as well clean the technology, because when you handle highly potent materials, you need to decontaminate. That's why the technology can transfer liquid as well for decontamination, and we can even use steam for steam sterilization for handling acetic powder. That's why a lot of possibility has been opened through this technology and really help our customer to optimize and to make their plant safer. Here on this platform, we are looking some of the module we'll be discussing about this advanced modular, or I would say configurable process plant. That's why this is more like a lab scale as a continuous process flow. And you can see some of the elements here. Usually, after a reaction step, you can go to crystallization. That's why here you can see our double-stage crystallizers, which is called oscillating baffled technology. The advantage of this is that you can create a better crystal. In fact, it's a semi-continuous operation, and you can grow the crystal in a way that it might be difficult into a batch reactors also. And you can have different stages of up to 3 to 4 stages of crystallization with different temperature mapping. If you move, the product will be moved to the next stage through special pumps, technology we developed to intermediate vessels, and then you could go after even to a separation on drying process. That's why here this technology is a continuous dryers, which we include filtration and drying. Is it based on filter dryer concept? It's a rotating revolver technologies with multi-chamber, which you can have as in a filter dryer, different step of process from washing, solvent exchange, on drying process. And that means from the beginning to the end, we can get the product within not even 1 hour produce, and up to a scale of this side, up to 1 kg per hour of production.